Hello guys, welcome to our class for today. We are still continuing with our lecture on frictional force, but for this particular class we'll be looking at frictional force on an inclined plane. Frictional force on an inclined plane. So please guys, if you have not subscribed to this channel, please click on the subscribe button. Also click on the bell so that when we upload any new video, YouTube will notify you. Please, you can also reach us through our WhatsApp number that is showing right on your screen. I remain Otobo Michael. This is Noble My Science Tutors Online, and we are bringing physics lectures direct to your very doorstep. So please invite your friends so that they can also join you in enjoying this particular lecture. You please also give a comment on the comment section and give us a thumbs up if you like what we're doing. So before you go to our class for today, please just get your writing materials and get settled. So right away, we are going to our class for today, which is frictional force on an inclined plane. So this is a typical inclined plane. Alright, so solid friction on an inclined plane. For an object to slide down an inclined plane, the coefficient of friction can be calculated first by looking at the setting. Right, if you look at this setting, you see that the normal reaction for this particular block that is on an inclined plane, this is an inclined plane that is inclined at an angle theta. Right, so the force that is pulling this block of wood down the plane is equals to the vertical component, which is the y component, and this is w sine theta. Then the frictional force F is equals to mu r is the force that is opposing the motion. Naturally, if you put any object on an inclined plane, it will tend to roll down. So this is the force that is pulling this object down, which is w sine theta, right, which is the vertical component of this force, or the horizontal component, that is the force along the plane. Okay, so this is the force along the plane that is pulling this object down. Then the frictional force that is opposing the motion is given by mu r. Then the force that is perpendicular to the plane, right, is given by w cos theta, which is equal to the normal reaction for this in this particular setting. So this width of this object can be resolved into two components. It can be resolved into the y, right, and the s component. So the component that is parallel to the plane, as I've said, is given by y is equals to w sine theta. Then the component that is perpendicular to the plane is given by w cos theta. Please take note of these two equations. Right, so from here we are going to derive the equation for the calculation of the coefficient of friction for an object that is on an inclined plane. Right, as an inclined plane, we have said that the component parallel to the plane is opposed by the frictional force that is acting in the opposite direction. So which means that for this body to slide, for it to slide, or for the body to slide down the plane, it must overcome this frictional force. It must overcome this opposing frictional force. So which means that F equals to U R, and which means that this F that is equals to U R, which is frictional force, must be equals to the component parallel to the plane, and that is what we have in this first equation. That's what we have in this first equation. So this force is equal to the frictional force is equals to the component parallel to the plane. Now for an inclined plane, the normal reaction is not equal to the width, but rather is equal to the perpendicular component of the width, right? So the normal reaction is equals to this. So that is this. It's equals to w cos theta. So for you to find the coefficient of friction, right, coefficient of friction is given by frictional force all over normal reaction. So if you bring these equations here, you see that frictional force here is equal to W sine theta, and normal reaction is equal to W cos theta. So for an inclined plane, this is the formula for finding the coefficient of friction, right? W sine theta all over W cos theta. Or alternatively, you can just find the tangent of the angle of inclination, right? Okay, so coefficient of friction, you can get it from the tangent of the angle of inclination. Is that okay? And this tangent of this angle is same thing as W sine theta all over W cos. If you consider this triangle that is here, you can get this equation from that triangle. So those are the two equations for finding. Those are the two ways of finding the coefficient of friction for an inclined plane. You can find it from either the components parallel to the plane all over the component perpendicular to the plane, or looking for the tan of the angle of inclination. Is that okay? So these are the two basic equations for finding the coefficient of friction for an inclined plane. So right away we're going to apply this equation that we just got in now to solve some problems, right? Don't forget this, that for an object that is sliding down the plane, if the object is sliding down the plane, it has kinetic energy. So the object is in a dynamic mode, so work done for this object that is sliding down the plane is equals to the kinetic energy. Is that okay? And the force that is moving this object down, that is parallel to the plane, is W sine theta. So the force is W sine theta at distance. So in case there's any question that has to do with this equation, you know how to apply them. Is that okay? So take note of that. Okay, so I'm going to solve a problem now. Okay, so let's look at this question. Question says that a body of mass 5 kg is placed on a plane inclined at 30 degrees to the horizontal. Calculate 1. The force parallel to the plane to slide it down, the normal reaction, then the coefficient of friction. Okay, so I have drawn the diagram already, so this is how it looks like, but please learn how to draw this diagram in case you are given a question, because it is not every question that will come with each diagram. If you can actually represent a question on a diagram, solving it becomes very easy, because you can visualize a question from the diagram that you have drawn. And this is very, very key. If you are answering wire questions, you should be able to represent some questions in physics on diagram. Your diagram alone can actually give you some scores. Is that okay? So please try to practice how to draw your diagrams, right? Okay, so for this particular question, you are giving angle of inclination to be 30 degrees. It's given to you already. I'll be giving you angle of inclination to be 30 degrees. Okay, so you have that. You have the width or the mass to be equals to 5 kg. That is given to you. Mass has been given to you to be 5 kg. So you are asked to find the force parallel to the plane. From our previous discussion, we said that the force parallel to the plane is this, right? So force parallel to the plane, which is the first question, F parallel to the plane is equals to what? W sine theta. So W is equals to mg sine theta. W is weight, right? So if you substitute into this equation, you are going to have that the force parallel to the plane to slide it down is equals to 5 times 10 times sine 30 degrees. Now sine 30 degrees from your calculator is equals to 0.5. So if you multiply that out, wow, 50 times 0.5, and that gives us what? If you multiply that, you have 25 Newton. Okay, so for this particular question, the force parallel to the plane is equals to 25 Newton. Right, so the number 2 says the normal reaction. Normal reaction, we say that normal reaction arrow is equal to what? W cos theta. That's what we said. That was what we arrive at, or what we discussed initially. So this will be equals to mg cos theta. Okay, so your mg, we already got that before, to be equals to 50, or just say your 5 times 10, let's say 50 times cos 30 degrees, 0.866. Okay, so that gives you, when you multiply all these out, you are going to have 43.3 Newton. So it's as easy as that. Just know which of the equations to apply. So this gives you the normal reaction. Okay, then the coefficient of friction, we said that coefficient of friction mu is equals to W sine theta all over W cos theta. So if you substitute these values that we have, you have 25 all over 43.3. So punch that out in your calculator. You are going to have 0.577 as your coefficient of friction. So we see that if you know the equation to apply, equations like this are very simple. Is that okay? So this is how to go about solving this kind of problems, right? This is how to go about solving this kind of problem. Also, alternatively, you can find the tangent, right? You can see that mu, which is the coefficient of friction, is equals to tan. It's equals to tan 30 degrees. Okay, so tan 30 degrees from your calculator is equals to 0.58. So this is the same with what we have here. Okay, so consider this is the same with what we have here. That gives you the coefficient of friction, right? So let's try another problem. Let's solve another problem. Right, so this is another question. A concrete block of mass 25 kg is placed on a wooden plank inclined at an angle of 32 degrees to the horizontal. Calculate the force parallel to the inclined plane that will keep the block at rest if the coefficient of friction between the block and the plank is 0.45. So here you are looking for the force. You know, naturally, when the block is on the plane, it is supposed to slide. So now you are looking for the force that will keep this block at rest, that will make it not to move. Now for this block not to move, it means that this force that is pulling it down should be equal to the frictional force that is pulling it up. So now we are going to solve for the force that is parallel to the plane, then we'll solve for this force and then find the force that is required to keep this block at rest on the inclined plane. Alright, so 32 degrees the angle of inclination, the weight is 25 kg. Alright, so having known that, so what we're going to do now is that you are be given here, you are given the weight or the mass. Mass is given to you to be what is given to you in your examination. You should be able to state them out. You are given mass to be 25 kg. Angle of inclination is equals to 32 degrees. Sorry for my writing, 32 degrees. Then you are given coefficient of friction is given to you to be 0.45. So now to solve this problem, you are going to find the component of the force that is parallel to the plane that is trying to pull it down. Then you also find the component that is pulling it up, which is the frictional force that is opposing this motion. So to find that one, component that is parallel to the plane is equals to force parallel to plane is equals to W sine theta. Okay, so which is equals to mg 25 times 10 multiplied by sine of 32 degrees. Sine of 32 degrees. So if you work this out, you're going to have 25 times 10 is 250. That is 250, and sine 32 degrees is equals to 0.5 0.5299. If you point that out from your calculator, so if you work this out, the force parallel to the plane will give you, point that out your calculator, you have 132.48 Newton. 0.48 Newton. So here we have gotten the force parallel to the plane, which is Fy. Put it as Sy, Fy. We've gotten this force that is parallel to the plane. Is that okay? Then the frictional force that is opposing the motion, frictional force that is opposing the motion, the frictional force that is opposing the motion, F, frictional force equals to F equals to coefficient of friction times normal reaction. Normal reaction is given to you to be W cos theta, and coefficient of friction has been given to you. So this one is intended as normal reaction multiplied by W cos theta. So if you substitute your values into this equation, you are going to have 0.45, which is in the coefficient of friction, multiplied by W cos theta, which is when you multiply that out, you are going to have 25, that is 250 times cos 32, and cos 32 is equal to, we use calculator to get that 0.848 is given to you to be 0.8480. Okay, so by the time you multiply this out, you are going to have 95.4. You have 95.4 Newton. Now when you look at this, if you look at this, you see that the force the force that is pulling, that is acting parallel to the plane, right, is greater than the frictional force, is greater than this. So the force that is keeping this object at rest is the difference between this force that is acting parallel to the plane, that is pulling the body down, and the frictional force. So for you to get that, it means you are going to subtract this from this. So that force, the force is equal to 132.48 minus 95.4. So when you subtract that out, you will have 37. You have 37.08 Newton. Okay, so this is the force that is required to keep this object at rest on this inclined plane. So when you look at the problem, you see this is just how to solve this kind of problem in case you come across this kind of question. That okay? So first of all, find the force that is pulling the body down, then the opposing frictional force, right? Then the difference between the two is the force that is keeping this object at rest. The difference between the two forces is the force that is keeping this object at rest. Okay, so I hope that is simple and clear. Okay, so thank you so much. This is where we're going to stop for our class for today. Thank you for your time, and I hope that you apply all this knowledge that you are getting from this lecture series. Okay, so this is your test your understanding page. Please solve this problem and then put your answer on that WhatsApp number that is displayed on your screen. Also, put your comment on the comment section. We'll look at all your comments and then add our own voice to whatever you have written down, right? So guys, if you have not subscribed to this channel, please click on the subscribe button, click on the notification button, so that when we're uploading a new video, YouTube will notify you. Also, you can reach us via the WhatsApp number that is showing on your screen. So thank you for your time. Please invite your friends to come and enjoy what you are enjoying on YouTube. We are grateful to you for being with us all this while. So thanks. See you in our next class.